Good morning, boys and girls. This morning we are looking at example number 5, and it's about the graph that you are seeing here. The graph is quadratic and we call it F, and this graph is passing through point Q, and its turning point is at point 03 and also passing through the point T. And that is our graph of F. And inside this graph we have R, Q, T, S, or you go Q, R, S, T in the order they appear in the alphabet. And the question reads, f of x is equal to ax squared plus bx plus a c, and g of x is equal to k. This is our G, this is our F. Our G is a straight line parallel to the x-axis, so its equation is known and its y is equal to -1. QRST is a rectangle. As I said, this is a rectangle, and the properties of a rectangle is that opposite sides are equal and each interior angle is equal to 90 degrees. With T and Q on F and R and S on G. This we can see T and Q is on F and R and S are on the equation or the graph G. Then it goes on to say, and S has coordinates P -1 on G. K here is the point S with coordinates P -1 on G. F casts the x-axis at -3 and 3, which is also indicated here. And then the y-axis at 3. This is what I alluded to when I was explaining the graph. Part A, determine the values of A, B, C, and K, which means all we need is to use the information we have here on the graph to answer that question. So our f of x is defined in this form, that's the standard form, and we can write it as in the x-cut form because we do have coordinates of the x-cut. So we shall have y is equal to a bracket x minus x1 into x minus x2. So using the point that we are seeing on this graph, which is 03, we can substitute our x values. It will be x plus 3, x minus 3. And therefore substituting our 03 as a point, we shall have 3 for the y, and 0, it means in this bracket we remain with 3, in this bracket we remain with -3, which when solved we end up with a is equal to -1/3. Now we can actually expand, substituting our a and expand. This is the factors of difference between two squares, which gives us that, which then reduces to that, which means our a is equal to -1/3. Our b, since there is no term in x, is equal to 0. Our c is equal to 3. Then our k is equal to -1. I think I mentioned it earlier on. This is the graph of y is equal to -1, which is the G graph. Part B says, state the coordinates of Q, R, and T in terms of P. When we talk of Q, R, there is our R. Our P definitely is the same here. So the coordinates of R is P and -1, which is what I stated here as well. The coordinates of P, of Q rather, of R are -P and -1. Because we are moving from here to there, it's a P. From here to there, it's a -P. Since this whole QRST is a rectangle. Then we also need the coordinates of Q. Since we know the x coordinate at R, we said it's minus P. So at Q it's also minus P. So we can substitute the coordinate of R here for x, which is into this equation, which happens to be y is equal to minus a third x squared plus 3. Therefore, we end up with the coordinates of minus p and minus a third p squared plus 3. And finally, the coordinates of t are p, and again we substitute the p in here, we end up with minus a third p squared plus 3. Then part C showed that the area of triangle QRST is given by that. What do we need? We need this length, we need that length. So what is QT? Q to T, it will be P plus P, because this is 2P. If this is 2P, then this is a rectangle. It means QT is also equal to 2P. Then we need our TS. Our TS is just the Y change from T to S, which means the Y coordinate at T minus the Y coordinate at S, which happens to be minus P 1 over 3P squared plus 3 minus 1. And we end with a third P squared plus 4. Now, therefore, the area of QRST is length times breadth, which means this times that, which reduces to minus 2/3 P cubed plus 8P. We have shown exactly what they said we should show. Then the last question is part D. Determine the value of P for which the area of QRST is a maximum. It is a maximum when we differentiate the area. So we are going to differentiate with respect to P. So we have minus 2P squared plus 8 is equal to 0. Therefore, P squared is equal to 4. Our P is plus or minus 1. But then P is positive. Therefore, P can only be 2. Simply because the reason is that P is positive. We are done with part D. Let's look at part E. Determine the equation of the tangent to F at x equal to 3. We want the equation. So generally our equation for the quadratic was y is equal to minus a third x squared plus 3. So we know our differentiating this, we end up with f dash is equal to minus 2/3. So the differentiation of the function is actually the gradient. Therefore, our gradient is equal to f dash of 3. F dash of 3. So which gives us a minus 2. So using the formula that we all know, y minus y1 is equal to m into x minus x1. We are talking about a point that we referred to as the point which is this point, and it's 3 and 0. The coordinates there is 3 and 0. So the y is 0, so it's y minus 0 is equal to minus 2 into x minus 3, which then reduces to y is equal to minus 2x plus a 6. Then we are doing our last example, which actually is the last example for the topic. Once we are done with this, when you do the classwork that we are going to give, we then know that we are done with calculus. I want you to also look at this graph. We have got two quadratic functions. One is a minimum turning point and the other one is a maximum turning point, which is actually given, and there is a point P on F and a point Q on G. And we notice that the graph of F cuts the x-axis at 3 and also at minus, it's not given. But the G1 cuts at 3 and at minus 8. And it also cuts the y-axis at minus 24. So the question reads, f of x is equal to ax squared is equal to x minus p, or this squared, plus q, and g of x is defined by k x squared plus bx plus a c. F has a turning point at minus 1, 32, which we can see there. G passes through the point minus 8, 0 and minus 24. And F and G both pass through the point 3, 0. Both of them are passing through that point. PQ is parallel to the y-axis. PQ is parallel to the y-axis with P on F and Q on G. Part A says, determine the values of A, P, Q, K, B, and C, which means we are just referring to all these ones here. This is in the turning point form. So we will look at this graph of F, which is this one. We can all see that the graph is passing through 32, which is the turning point. So we have A bracket x plus 1 in brackets squared. This is the turning point form. Remember, this is a minus 1. So it becomes x minus minus 1. So it's now a plus. So using any point that we know, there is a point here, which is 3, 0. Y is 0. And then we shall substitute our 3. If you substitute 3 here, it becomes 4. So it's 4 squared plus a 32. Solving, our A is equal to minus 2. So substituting back our minus 2, it goes x plus 1 in brackets squared plus 32, where we can actually read our values for A. A is minus 2, which we can see, and P is actually a minus 1, because this is supposed to be x minus P. And then our Q is the y cut, which is the y coordinate at the turning point. So we have solved for A, P, and Q. We are left with K, A, K, B, and C. So with that one, we are saying g of x is equal to, we use the x cut form because both x are known. The graph cuts the x-axis at 2 points that are given. So it will be A bracket x plus 8 into x minus 3. Now, when we substitute a point, there is a point that is known on this graph. And this point is minus 24. So it's 0 minus 24. So minus 24 is equal to 0, 0. That's minus 24. When we divide, we get our A is equal to a positive 1. We now know our A. But our A is our K according to the standard form that we are given. Our K and this A that we found is the same. So our g of x will be equal to x squared plus 5x minus 24. When you expand this, if this is 1, expand this, you end up with that. Therefore, our K is equal to 1, our B is equal to 5, our C is equal to minus 24. Then we are doing part B. Determine an expression for the length of PQ in terms of x. Now we are talking about this length here. So what do? We go to this equation, the equation of F minus the equation of G will give us, in actual fact, we are talking of the y coordinate at P and y coordinate at Q. At P, the y coordinate will be by simply substituting the equation f of x and then subtract the equation g of x. So that is why here I have the two equations that we calculated, this one and that one. So it's this equation minus this equation, but we make sure we are making use of brackets. That is why we have this minus that, which gives us that. This is the expression of the length of PQ in terms of x. Then the question goes on to say, determine the value of x at which PQ is a maximum. So to maximize, we differentiate. Differentiating, we shall end up with minus 6x minus 9, which then when solved, when we equate to 0, we have our x is equal to minus 3 over 2. Then that is the x value that we are required to find when we maximize. And to maximize or to minimize, we differentiate the given expression. Part D, it says, what is the maximum length of PQ? Just like we have been doing, our PQ is actually the expression that we got. This is our PQ. So we are substituting the x value in this expression. So it will be minus 3 into minus 3 over 2 squared minus 9 times minus 3 over 2 plus 54, which when you simplify, you get 27 over 4 plus 27 over 2 plus 54, which reduces to 60,75, or you can write 60 and 3 over 4. Boys and girls, your last classwork for this topic will be classwork exercise 14. I want you to do numbers 7 and 8. I thank you.